Hello student of Calculus 2. Today we will discuss a different type of series than what we have seen so far, which is the alternating series. Now what we have seen before is only a usual series, and we said it will be always positive. Okay, so we doesn't allow any negative sequence here. Now for the alternating series, things are a little bit different because if you remember the alternating series, it always looked like plus and minus. So there is a minus, plus, minus, plus, minus, plus. This is the characteristic of alternating series. And the formula that we will use is we have a positive part, Pn, and then we have the alternating part. That will cause only plus and minus. So just let me write it here, alternating part, or we call it plus minus. So we have the alternating part, plus and minus, and we have the positive part, which is just positive. Okay, and then if we write it down, it will be B1 minus B2 plus B3 minus B4, 5, 6, and 7, and so on. Now, it doesn't matter we start with a plus or minus. The only matter is that it is plus minus, plus minus, plus minus, and it goes to infinity like this, plus minus, plus minus. And this is exactly the alternating series. Now, just to give you an example of a famous alternating series, we call it the alternating harmonic series. What is the alternating harmonic series? It's the same as the harmonic series. If you remember, the harmonic series was 1 over n. That's the harmonic series. The alternating one, it will be just the same as it is, but we have the alternating part. Now, the alternating part is the one that will be responsible for plus and minus. That's all. It will not do any other harm to your series except the plus and minus. So just be careful of having this negative 1 to the n. Sometimes it's negative 1 to the n. Sometimes it's negative 1 to the n minus 1. Sometimes it's negative n to the n plus 1. So it has different formula, but the only way you check, try to expand a few terms and see, is it plus minus? You will make sure that, yes, this is alternating one. So this is the harmonic series test. Now, as usual, we have a question. Is this convergent as a series or divergent? Are we, if we add plus minus, all those numbers, if we add them, do we get an answer? Or will it just go to infinity, minus infinity, or even does not exist? We never know what will happen. Now, in order to find if it's convergence or divergence, we cannot use the test like comparison test, limit comparison test, integral test, because those tests were for positive series. In this example, this is alternating series, so we have a special test for it. We call it alternating series test, AST. A special test, special checking, special steps. It will tell me if the series convergent. Let me show you this beautiful test. It's in this slide here. We have alternating series, plus minus, plus minus. You need to check only two simple things, and that's why we like the alternating series test. It's very easy to use. First, you need to check that Pn is decreasing. What do we mean by decreasing? It means with the time, the numbers of Pn getting smaller and smaller and smaller and smaller and smaller. And then that means every term is larger than the next one. So the numbers are getting smaller, And then the last one of them must be 0. So the limit is 0. So they are getting smaller and smaller, and the last one is 0. If this has happened, the series will converge. Now, if they are getting smaller and the last one, which is the limit, is not 0, maybe 1, stop. This will not be convergent. Now, if the sequence from the beginning is not decreasing, it's going up, not going down, it will not convergent. We cannot say it's convergent using this test. So just we have to check two things. We have to check the sequence is decreasing, and this usually will be using the derivative. Make sure the derivative is negative, and the limit is 0. So that's exactly. For most of the questions, I will start checking condition number 2 because it's the most one that will fail. The first one, most of them will be decreasing. Most of our series sequences are decreasing. But the second one is no, we have to start with it. So let me go ahead with an example. And we'll do it here. So here, solution. First of all, this is alternating series. So we have to use the two checking steps. So I will start with step number 1. But before I start with step number 1, I need you to tell me what is Bn. Now, in this question, Bn is clear because I get -1 to the n. So I just forget about this. Everything else is Bn. If it is not clear, then you have to write a few terms, plus, minus, plus, minus, plus, minus, and then find Bn. We'll see that in different examples. So here we have 3 plus 5 and 1. Now the first checking step is going to infinity of Bn. This is just the limit. Sn goes to infinity. 3 plus 5n. Now if you substitute infinity, you get 1 over infinity, which is 0. 2. So we are fine. Now we have to check the first step. Now you need to tell me what is the function that is similar to Bn. It will be 3 plus 5x. And then we find the derivative. I think we will use chain rule. We can use the chain rule. Or the quotient rule, doesn't matter. Square minus 5. I just use the quotient rule. This will get. Now, is this positive or negative? It is negative. Why negative? Because you can see there is a minus and there is a square here. So this is always positive, positive, negative. So this is negative. This is positive. This is positive. This combination will give you a negative. So Bn is decreasing. And hence the series, and then you write the series again. Is convergent. And then you have to write the reason. By which reason? By the alternating series test. And that's it. Or by ACT. I hope this example was clear enough to show the alternating series test. Let me go to the second example. First of all, it's clear this is again alternating series. I can see the -1 to the n plus 1 and everything else is the Bn. So here is the solution. Which is n squared plus 1. Now I will check number 2 as I said. Sometimes if number 2 doesn't work, we cannot use the alternating series test. And most of the time, number 2 is the one that might not work. Now, this limit is very easy, very simple limit. The answer is 1. Now, if the answer is 1, what we expect it to be 0. Now, if the answer is 1, I will write, let me write it a different clear color. Let me just do customized color for this one because it's very important. I would opt for an orange one. Now, the series divergence. It's not convergence. The answer is 1. Now, why the series is divergent, and this is why I wrote it in orange, because which test I use? I use the test for divergence. Do you remember the test for divergence? The test for divergence is telling me if you have any series, look at the last term. If it is not 0, divergent. And that's exactly what happened here. I looked at the last term, and the last term is not 0, so I use the test for divergence. Don't write for me here by the alternating series test. That is X. It's not the alternating series test. Okay? It is the test for divergence. Alternating series only will tell you it is convergent if you check the 2 conditions. So I hope I made that crystal clear here. Now, next one, I think we are familiar with next one. We have seen it before. Is this alternating? Well, it doesn't look like alternating, but remember, cosine n by, it is an alternating one. It is plus minus n by. Also, sine n by over 2. If you don't believe me, plug in values. Put n equal 1, n equal 2, n equal 3 here. 1, 2, 3, 4, 5. You will see the answer is plus 1, minus 1, plus 1, minus 1. So this is alternating. And then your Pn will be n over 2n. And then apply alternating series test. I trust that you know how to do this. And I'm sure you know how to do this. So I'll just leave it for you to practice it more. Okay, next one is this one. I mean, this is a clear and alternating series. We need to do the 2 checking. So I will just do one of them and see what happened. I will just try to find the limit as n goes to infinity of this one. Here, unfortunately, I cannot directly use L'Hopital. If you want to use L'Hopital, you have to find a denominator and a numerator, which is, we don't have it at this time. So I will use the idea that you have seen it in Calculus 1, which is multiplying by the conjugate. Sometimes this is always helpful if we have root and root. It's always nice to multiply by the conjugate. Now, if you multiply by the conjugate, let's see what we will get. First with the first, it will be n plus 1 minus n, and then this one, which is just 1 over this one. Now, if we do direct substitution, we will not be able to find the answer. It will be the same as before. So the conjugate was not a good idea after all. That's how you start thinking of mathematics. You try one way. If it doesn't work, you stop, you reflect, think about something else, and then you just need to do it. So this idea doesn't seem to be working perfectly. Unfortunately, that happened to us. So we have to find a different, maybe a different way. Maybe you can use L'Hopital rule, and in order to use L'Hopital rule, we need to find denominator and numerator. So I will leave this one out, and we'll do a different trial. Now, in order to use L'Hopital, maybe the first idea, of course, this will be infinity minus infinity. As I said, L'Hopital is a little bit tricky. I will just take this one as common factor. I will get this one minus this one, which I think I can simplify this one a little bit more. Square root of n, square root of 1 plus 1 over n minus 1. Now, this is, if you do direct substitution, will give you infinity times 0. Now, infinity times 0, we can also do something for it, if you remember, and we can change it into numerator and denominator. So we have 1 over square root of n, and here we have 1 plus 1 over n minus 1. I guess now we can use L'Hopital rule. No problems, not problems at all. Take the derivative of the numerator. Derivative of the numerator, it will be 1 over 2, the same square root. And then the derivative of whatever inside it. Derivative of this one, this is the same as n negative half, so it will be negative 1 over 2 n root of n cube. Now I'm sure if you simplify this one, this is 3 over 2. I think the answer will be 0. Try it at home. The answer should be 0, and the series is decreasing. This is a tricky one. I would like you to go through the steps of this one. So please do it, try it, and practice it. Okay. Last question is this one in the alternating series, and you can see that we don't have Pn clear in this question. So we have to find what is Pn. We have to write Pn. Now it's alternating. I can see that is alternating. That's fine. Now what can you see about this series? It's start with 2 at the top. 2. Look at the top. 2, 4, 6, 8, 10. Those are even numbers. And how do we write even numbers? Usually they are 2n, starting with n equal 1. Check for me. If you put n equal 1, you get 2, 4, 6, 8, and so on. Now what happened down here? It's only 5, and then 6, 7, 8, 9. So it's only added by 1. So this is will be n plus 4. Why I wrote 4? Because how do I get 5? By adding 4 if it's starting with 1. Now if you start with 2, you get 2 plus 4, 6. If you have 3, you get 3 plus 4 is 7. So this is my Bn. And now if you apply the alternating series test, the limit will not be equal to 0. I think the answer will be actually 2 instead of 0. So let me go to the orange. What can you say about the series? As divergent by the test for divergence. Thank you very much for watching this video. The next video will be about error estimating.